Hi guys and welcome back. In this video I will be talking about the conduction blocks or the AV blocks. Basically the conduction system starts from the SA node. The impulse from SA node will travel to the AV node. From AV node they enter into the bundle of his. From there they enters into the Purkinje fibers. Okay. In general in AV block there will be a conduction delay or there will be complete blockage of impulse. Complete blockage of impulse. So from SA node, the impulse sent to the AV node and from there to the ventricle through the Purkinje fibers and his bundle. In ECG, if you see the PR interval, this is the P wave, this is the P wave, this is the R wave. So the PR interval represents the duration, the gap between atrial depolarization and ventricular depolarization, that is the gap between the atrial contraction and ventricular contraction. In general the PR interval will be 0.1 to 0.20 seconds. So in AV blocks in AV blocks, based on the degree of block and type of block, there will be different types of changes that we can observe in the ECG. So the common finding is there will be a delay or prolonged AV PR interval. Delay in delay or prolonged PR interval will be observed. So let's see the ECG representation of different types of heart blocks. So here you can see the first degree AV block. The first degree AV block. Look at the P wave first. Every P wave is followed by QRS complex. T wave, P wave, QRS complex, T wave, P wave, QRS complex. So this is like normal pattern, following the normal pattern. But look at the intervals. Look at the PR interval. So let's see one big box. This one big box is equals to 0.20 seconds. Okay. Here, let's count. Here, the gap between these two, the P wave and the R is more than one large box. Okay, more than one large box means it is more than 0.20 seconds. Okay, right? Here the P wave, this is the P wave and this is the R wave. Okay, this is the R. Okay, the gap between these two, the PR interval is always, it is more than one large box plus half of the large box. Okay, this is somewhere around 0.10. So the total is 0.20 plus 0.10, it is 0.30 seconds, right? So what is the normal PR interval? It is 0 point, the maximum is 0.20. If it is more than that then it indicates prolonged PR, right? This is prolonged PR interval. This is type 1. So one more significant finding in type 1 is there is no skipping of ventricular depolarization. All the impulses from SA node through the AV node will be passed to the ventricle, but with some delay. With some delay, they will be passed. There is no blockage of impulse. All the impulse will be travel to the ventricle with some delay. That is the PR interval delay. Let's look at the second degree AV block type 1. The second degree heart blocks are divided into type 1 and type 2. So the type 1 and type 2. The type 1 is also called as Van-Kenbach phenomenon, right? So the type 1 is called, which is very important. This is Van-Kenbach phenomenon. So let's see the ECG of type 1 in second degree heart block. Let's, like every ECG, we need to follow the same pattern. The P wave, QRS complex, T wave, P wave, QRS complex, T wave. So P wave, QRS complex, T wave, P wave, and there is a skip of QRS complex. Skip of, that is no ventricular depolarization, absent of ventricular depolarization, right? So here SA node and AV node and ventricle. So the impulses generated from the SA node, they are travel to the AV node, and initially there will be a some delay. The delay will be progressed slowly. Here you can observe that thing. Let's see. Initially the gap, the PR interval is less than 0.20 seconds. Here it is almost 0.20 seconds. Okay. Here you can see there is a almost one and a half large box is there. Here one and a half large box is there. That is more than 0.20 seconds. So if you observe, it is less than 0.20 seconds, almost 0.2. The PR interval is progressively increasing, and there is a skip of QRS complex, right? So how will you define that second degree type 1 heart block is? What are the features that you will observe? There is a progressive PR interval prolongation along with skip of QRS complex, right? I think you understood this. So progressive prolongation of PR interval, and there is a skip of QRS complex, right? Next, let's move to the Mobitz type 2. So this is Mobitz type 2 or second degree heart block type 2. Like every ECG, you follow the same pattern: P wave, QRS complex, T wave. This is P wave, there is no QRS. P wave, QRS, P wave, QRS, P wave, QRS, there is no QRS. So QRS is skipping. In type 1 also there is a skippage of, in type 1 of second degree heart block there is a skip of QRS complex. Then how will you differentiate between type 1 and type 2? Let's look at the PR interval. So here in type 1 there is a progressive prolongation of PR interval, right? So here look at the type 2 of second degree AV block. The PR interval will be constant. Okay, the PR interval will be constant in every time. Okay, the PR interval will be constant. So how will you define type 2 second degree heart block? Type 2 second degree heart block. So let's see. Constant PR interval that is less than 0.20 seconds. You can see it is normal PR interval. Okay, this is normal PR interval less than 0.20 seconds. And second thing is sudden skip of QRS complex. Sudden skippage of QRS complex. Let's see, before talking about the third degree heart block, let's see some basic thing. SA node, this is AV node, this is ventricle. So when the AV node is completely blocked, this is completely blocked. So the impulses are not travel to the ventricle. Then what ventricle do is it will contract on its own. On its own, it will contract. Okay. But the impulses from the SU node are regular. Regular. So impulses from SU node will reach the atria. Atrial depolarization is represented by P wave, right? So the interval between two P waves will be constant, where in third degree heart block. Okay, in third degree heart block, the AV node will be completely blocked, right? But the impulses from the SN node are constant and regular. So you can see that the PP interval will be constant. But the ventricle contracts on its own, but the ventricular contractions are not regular. So you can see a QRS complex here one, here one, here one, here one. It is irregular. But when you see the SA node, atrial depolarization or atrial contraction, there are regular P waves. There are regular P waves with regular interval. Okay, so let's look at the ECG. Here you can see this is a P wave, this is a P wave, this is a P wave, P wave, P wave, P wave, P wave. So from the SO node, the impulses are regular and constant. So here you can see the PP interval, the atrial depolarization will be regular and constant. But look at the QRS complex. Here there's a wide gap, there's a wide gap, there is no QRS complex. And the P wave is not followed by QRS complex. P wave is not followed by QRS complex. P wave is not followed by QRS complex. So how will you define type 3 heart block? Type 3 heart block. So here, how will you define is there is a regular PP interval, regular PP interval and irregular QRS contraction complex or ventricular depolarization. This is also called as isolated ventricular contraction. The ventricle contractions are isolated from the SA node or atrial contractions, right? So ventricular contra contractions, right? So let's summarize the thing. Let's see what is the normal PR interval will be 0.1 to 0.20 seconds. This is the normal, right? Look at the type 1, type 1 AV block. In type 1 block, there is a constant, there is no progressive, there is no progressive, but prolongation of only prolongation of PR interval will be present, right? In type 2 or second degree sorry, this is sorry, this is first degree, this is second degree type 1. This is also called Van-Kenbach phenomenon, right? So here there is a progressive prolongation of pair interval with the QRS skip of QRS complex. So in type 2, let's differentiate type 2 and type 1. This is type 2. Here, in type 1, there is a progressive prolongation of PR, but in type 2, PR interval will be constant, but there is a skip of QRS complex. In type 3, what is type 3? Sorry, not type 3. This is third degree. The third degree is isolated ventricular contractions, right? I hope you all understood this concept and thank you for watching this video. Thank you so much.